Hello and welcome, everybody. Happy Thursday. Appreciate everybody taking the time to join our AI workshop, Unlocking the Power of Modern AI, Mastering LLM Ops. And we have to laugh because we're pretty much assuming anyone on this webinar is fairly technical, because if you're not, you wouldn't know what LLM Ops is and probably not be joining this. So we really appreciate everybody joining. My name is Steve Taplin. I am the CEO of Sonatify Technology. Joining me here is Dr. Antonio Tamayo, who is our lead AI engineer. And we have a really in-depth agenda that we are going through here today. We're going to talk about LLM ops, models, generative AI, the hardware and infrastructure needed. We very much encourage questions and in the comment section. The more interactive this can be, the better. And we are looking forward to this. And as I see, we still have a lot of people coming on board. Some interesting stats right now around AI. We all read what's going on in the news, all the good and bad AI news, and some interesting stats I wanted to share as people are still joining here is in as of 2024, the average tenure of CIOs and CTOs is only 2 years, which is pretty crazy. And in 2024, there's been a noticeable increase in turnover in those top technical positions. And the top reason that organizations are giving these people, CIOs, CTOs, or other tech leaders, of why they're being let go, is that their organization has the perception that they haven't fully embraced AI. And the crazy thing about that is most non-technical leaders don't understand AI. And even us technical folks, most of us have varying definitions of what AI is and its capabilities. And hence, why we're doing this workshop, why we like to continue to do education. Dr. Antonio Tamayo has a PhD in computer science with an emphasis on AI, machine learning. He has doctoral studies published around AI and machine learning in various industries. And so we're excited to jump in here to talk about this. Some other interesting stats: global AI markets expected to reach 738 billion by 2030. Venture capital investment and private equity investment last year in AI reached over 50 billion. And one of the interesting things that's all over the Wall Street Journal lately is that Wall Street is getting very impatient for profits to emerge from AI. There's been all this investment, all this talk about productivity. There's this growing concern from Wall Street around where are the profits, the increased profits from the AIs we're doing. And surprisingly, 77% of employees have reported that AI has actually increased their workloads and hurt their productivity versus helped it. And, my take on that is it's a new shiny tool and people are playing with it. They're figuring out how to use it. And this is all part of the learning curve of getting things forward. So real quickly, I just want to talk about Sonatify Technology. We are a custom software development company headquartered in Scottsdale, Arizona. We focus on modern cloud and mobile applications. Our AI consultancy has helped numerous companies across industries taking that leap of getting started with generative AI and doing those things to impress the non-technical C-level execs, non-technical shareholders, investors, and board. And that's a big part of what we're focused on. And our AI practice, part of what we do are these LinkedIn Live workshops. We offer one-on-one workshops with your company. We actually offer free AI assessments and roadmaps for companies, as well as we actually will put together free proof of concept models customized around your data. All a key part of what we do at Sonatify Technology. And our goal is to educate, to arm companies to really do all of these things without us. But if you get stuck or need help, we're here and we want to earn your trust through knowledge. And so, once again, as we continue to have people coming on the webinar here, if you signed up for an LLMOps webinar, you clearly know something about AI, because LLMOps is not something the common person knows what it means. And the common person, I don't even think right now knows about LLMs unless you're in the technology space. But we're all familiar with common LLMs out there like ChatGPT, BERT, Llama, and LLM Ops is really about the life cycle of these large language models, from developing and training the model, deploying it, how you monitor it, and how you continuously train it and have maintenance of that. And we're going to go in depth into these areas, but I wanted to start off with more of a high level view, just explaining what it is while we drill down into it. And our AI webinar last month we did was around AI in the healthcare and life sciences industry. We had over 300 technical and business leaders on that call. For this today's webinar, we had over 360 people register for this event. So we're very excited that we're going deep, providing useful information that technical and business leaders want to hear. And so we're excited to jump in here. So with that, I'm going to hand it over to Antonio, our lead AI engineer, to start diving deep here. Antonio, the floor is yours.
Thank you, Steve. And hi, everyone. I'm really excited to stay here for this next AI workshop. And first of all, from an educational perspective, I would like to say that so many people is talking about artificial intelligence right now, but we need to understand that artificial intelligence is not only generative artificial intelligence. That's a very common explanation that I'm doing every day, because artificial intelligence is a very huge area. We have different sub areas of knowledge inside artificial intelligence, such as machine learning, deep learning, and we have to say that generative AI is just a part of deep learning, and deep learning is inside of machine learning. And to carry out generative artificial intelligence, we need large language models. So that's the most important aspect to consider here. Let me go to the next slide, Steve. And maybe we may wonder why now? Why we're talking about artificial intelligence all the time? And we need to consider that this is the moment of the history where so many things converge. Uh, Nowadays, we have the most powerful mathematical models that we have seen, we have ever seen, and we have the infrastructure that we need to train those type of models. So we have the success of generative AI that we are seeing today is due to the sophisticated mathematical and computational methods that we have. And you know what I mean? I'm talking about the most recent deep learning models that we have, and the huge data centers and the infrastructure that we have available to train and to use the most recent advances, technological advances in artificial intelligence, right? Go to the next one.
So, Antonio, let me ask you a question here. But, as we sit here, July 25th, 2024, why is it such a current pivotal moment for AI advancements right now, particularly with generative models? What is the key compelling thing of why it's so pivotal right now?
That's a very good question. I would say that there are two reasons to think of that. Maybe the first one is nowadays we have very powerful models based on artificial intelligence, we can see that the models that we have available right now can get things such as humans doing, right? We have a very powerful models right now. And the other important aspect is that we can use the most recent advances at affordable costs, right? I think those aspects are very relevant to answer that question.
Gotcha.
Okay. And it is important to mention that the cost of computer storage has been declining over the years. So that's very important because when we are talking about generative AI or the most recent advances in artificial intelligence, we need to think in models that are using a very huge amount of parameters. So we need a very powerful infrastructure. And this is a very important aspect because right now we can access to these technologies, as I mentioned, at affordable cost. So that's very important, as you can see in this graph.
Antonio, I guess that's why so many new data centers are constantly being built, because the storage costs have gone down so much, and now the need for processing power and storage with the capabilities of generative AI have really drive demand.
Mm-hmm. Yeah, that's a very good point. And maybe we may wonder why is hardware and infrastructure relevant, and that's a very important point in this introduction because, for example, when we use the most recent advances in artificial intelligence, specifically for generative AI, are based on large language models. And when we talk about large language models, we need to talk about the parameter significance. So more parameters capture complex word relationships, as I will show you later on in this presentation. So that's very important because the results that we are getting with using artificial intelligence right now is due to these capabilities. And in order to achieve better results, we need more and more parameters. So that's very important. And that's the reason for the cost of the infrastructure that I'm talking about, right? Go to the next one. So nowadays, with large language models, we have a very huge amount of general applications. So we can talk about text-to-text models, text-to-image models, text-to-audio models, and so on. Here you can see different examples that we have, and different applications and companies that are offering a lot of models, a lot of technologies using generative AI. But with when we talk about artificial intelligence, we need to talk not only about generative AI, as I mentioned, because we can use large language models for other type of tasks. For example, for sequence classification tasks or sequence labeling tasks, and so on. But it is well known that the most spread use of the artificial intelligence right now is generative AI, and this is really powerful. But here you can see that we have several applications, and maybe the most important aspect to consider here is we have so many different applications, so many different softwares, but maybe we may wonder about a customization, right? Because I have my own business core, I have my own processes, and I'm thinking of how can I apply artificial intelligence to solve this specific task in my domain, for example. So this is very general, but I would like to say that we can adapt maybe all the examples that we have here to solve a specific task in our domain.
No, Antonio, as when we're working with clients focused on creating solutions for them, and as you have all these generative model examples out here, it's the approach that we often take is there are a lot of AI models already built out there that handle all of these generative functions and models that are here. And you never want to recreate the wheel and create your own if you don't have to. And there are certain websites out there that are aggregator websites of all of the AI models out there. And we have one in particular that we use with our clients, and it's called there's an AI for that.com. And it is one of the larger aggregators of all these things. And so many times when we're implementing solutions for clients, it's not a matter, we don't have to, and we don't want to customize more than what we need to. We want to look at what's out there with all these different models that are shown on this slide, and the right way to implement it in an organization. And you can't go from having no AI to having a ton. It's got to be stepping stones, or else getting your team more productive, making tasks more productive will often not go as well as everybody would like. Hence, the stat I mentioned when we started, around 77% of employees right now think AI is making them less productive versus more.
Yeah, I totally agree. Nowadays, we have an explosion of artificial intelligence based applications. Maybe you can find whatever you want to do, very general tasks. But when we are talking about some specific processes and in industries, maybe we will need the things that we will talk about later on in this presentation, right? Because sometimes we will need more specific development. But the good news is we have the artificial intelligence and large language models to do so many things. We need to trust in that, right? So, from an educational and a high level perspective, I want to talk about the functionality of large language models behind the scenes. So, in this chart, you can see that we have that to train a large language model, we need a very huge amount of data, right? A very huge collection of documents. Maybe if we are talking about text, but we can talk about images and whatever you want. We are talking about information, structured or unstructured information. So behind the scenes, a large language model is a type of language model, right? And what is a language model? A language model is an algorithm that try to predict the next word given some words, right? So that's the key point here. Because when we talk about generative AI, we can see that we can ask some question or put something, and we will get a response. And behind the scenes, large language models are only predicting the next word in a text. So that's the key point. But maybe we may wonder, how do LLMs work behind the scenes, right? So that's a good question. The powerful behind large language models is based on the architecture, the deep learning architecture that we are using to train the models. We're talking about the transformer. But before the transformer, we have LSTMs, GRUs, and other deep learning based architectures. And we have the backpropagation algorithm. And if we go back, we have the multi-layer perceptron algorithm, right? So this is the combination of very interesting mathematical models, algorithms, with the power of the infrastructure that we have available right now to train those models. Because we are talking about millions of parameters to train these models, and we are talking about million of documents, million of images, right? So that's the power that we have behind the scenes here. Um, Maybe later on in another AI workshop, we can talk about the details that we have here. But the most important key here is to understand that a large language model is just an algorithm that is trying to predict the next word in a text. But let me go to the next one.
So let me ask you a question here, Antonio. So at the highest level, so understand the algorithms about predicting the text, but what key mechanisms make it seem so human-like with the text that it's generating?
Yeah, that's a very good question. Inside the transforming architecture, we have a mechanism that we call the attention mechanism, right? And the attention mechanism is important because it allows to learn a very accurate representation for each word, right? We need to think that we are dealing with texts here, but behind the scenes, all the machine learning and deep learning models are dealing with numbers, right? So we need to represent texts, words as a numbers, as a vectors, right? As a vectors of numbers. So the power behind the scenes is to read a huge amount of text in different contexts, and using the attention mechanism, we can learn the better representation for each word, depending on the context that we can find it, right? That's
It,
the most
it's
powerful.
pretty, I think what makes the current generative AI models out there so impressive is that exact concept, how it's figured out how to make it human-like, or what I will say, understandable to non-technical people, just in human language. So that was a great explanation of that.
Okay, that's good. So we can say that to understand how large language models work, we have an extensive neural network behind the scenes. We have the transformer, and we have a whole deep learning architecture working with an input text and transforming the input text in the better representation in order to achieve a goal. So it is important to mention that the task that we tackle when we are training a large language model, it doesn't matter, because we're trying to predict the next word in a text. But if we have the text, we know what is the next word. So we may wonder, what's the goal here? That the most important aspect is in this architecture, we have a layer when we can save the representation for each word. And that's the key point. With those representations for the words, we can predict later on something. We can get a text with a very good syntax and with sense for a question that we want to do, right? That's a very interesting point. And we have also sophisticated algorithms. We have the attention mechanism that I mentioned before. We have massive data sets to train these models, and that's very important because sometimes you can think as a CEO, for example, or a CTO, I don't want to use GPT because I'm thinking of the security of the data. I want my own large language model. Yeah, that's a very common question. But you need to consider that the results that we're getting right now from GPT, Llama, Cloud, whatever you want, is due to the huge amount of data that they use to train models. So training a large language model from scratch it is possible, of course, but maybe you won't get the best results or the results that you are looking for. So that's a very important part.
So,
And maybe,
Antonio, I'm an old guy, and when I was young, the most common game was Pac-Man, and how Pac-Man's constantly going through, eating all those dots and never full. And that's how I describe AI and large language models. They have this need for constant data, and if you don't have enough data to base it on, it's going to very much be limiting. What,
yeah.
Antonio, what would you say right now are the main limitations of LLMs and how it's impacting practical applications?
um, for practical applications.
I mean, what do you think are the main limitations of LLMs right now?
Okay, about the limitation. Okay, let me go to the next one. To talk about that. Yeah, that's a very important question because right now we can achieve impressive results using large language models, but we need to talk about the limitations. That's very important. One of the limitations could be the security or the risk with the data, but we can deal with that because we can do so many things, and we can work with APIs, and we can ensure the data security. Right? That's a very important aspect, but we need to talk about other limitations. And obviously, we have limitations. We need to talk about outdated knowledge, for example. When we use a large language model, we are using a model that was trained using some data, and the data maybe is outdated, right? When you use GPT, for example, you are using data until the last year, for example. So you need to consider that, because if you are dealing with updated information every day in your processes, you should think of that. So that's a, for example, an important limitation. The inability to take action, for example, this is a very important limitation for large language model, but it is not for large language model operations. I will talk about right later on. The lack of context is another type of limitations when we are talking about large language models, because so many times large language models wasn't trained with the information that you need to solve a specific task. So we need to consider that. The next one is a very interesting limitation: hallucination risks. So many people are talking about this, but hallucination risks is a very interesting limitation. When you use a large language model, you can ask whatever you want, and the large language model can retrieve a text which is good, right? When we are talking about syntax, right, grammar, but the large language model can talk about an hallucination, right? Yeah. So that's due to the large language model did not have the information associated with the question that you're asking. So that's really
This has definitely been a hot topic in the market. I have a Forbes article that's in progress
Mhm.
around hallucination risks with AI, and I kind of compare it to it could bring something out that is completely not true or way out of context. And I kind of describe it like teenagers get their news from TikTok. That
Mhm.
that I kind of equate that to hallucination risks as far as the wildness of the data that can come out of there. That's definitely a hot topic right now.
Yeah, that's it. And another type of limitation is the bias, for example, bias and discrimination. This is a very important aspect. There are researches to tackle this type of problem. I would say that this is a problem, not a limitation, because if we are planning to use generative AI in our domain, we need to consider this point, because a biased large language model is completely dangerous, right? So we need to consider that. Lack of transparency is another type of limitation. That's a very interesting limitation also, because it's related with the interpretability that we want to have in this type of architectures. But when we are talking about deep learning and all the neural networks architecture, we need to know that we have a black box, right? So that's a very important limitation also. And finally, we have a context limitations and token context length. I want to say something about this last limitation, because so many people are using ChatGPT, for example, and we can upload a file in ChatGPT and we can ask something to extract information, for example, for uh, from this file. But when we use large language models, we have a limitation in the number of words that we are dealing with, right? So we have a limitation of 4,000, around 4,096 tokens. You can understand tokens as a word. So if you upload a very large document and you're asking something about the final of the document, you won't get good results, right? So that's a very important limitation. But we are talking about the limitations of LLMs, but we have large language model operations. So let me go to the next one. So we may wonder, how can we mitigate the limitations of large language models? So here is where large language model operations appears in this end, right? We have different approaches to tackle the large language model limitations. For example, nowadays we have a very interesting approach called retrieval augmentation, right? We can use that. What is retrieval augmentation? We can improve the results that we are getting from a large language model using external resources. So we can combine the responses of a large language model for any specific task with our own resources. So we can combine all of them using retrieval augmentation, right? So that's very interesting. Another approach is chaining. So when you have a very complex task, you can split the task in subtasks, right? And you can put all of these tasks in an independent chain. And we can call the large language model for all of those tasks, and maybe we can get a better result. Also, we can use prompt engineering. Maybe you have heard about prompt engineering, but prompt engineering is not only to put something in a clear manner using my language, my native language, for example. We have several approaches in prompt engineering. We have zero prompt, right? Zero shot or few shot prompt engineering, for example. In zero shot engineering, you are using a large language model without any examples, right? But you can use examples. You can teach the large language model to achieve a specific task, showing examples, right? So that's a very interesting approach, and maybe later on we can talk about the details of prompt engineering. Is
And
exactly.
Antonio, prompt engineering is, to me, one of the most fascinating concepts of how do you get the most out of these LLMs and how do you get the best retrieval. And, as recent computer science graduates have had challenges getting jobs with the way the tech market is, I am always coaching and educating them that at the minimum become an expert at prompt engineering. And in fact, you don't even have to be a computer science major or have a overly technical background to concept or to grasp the concept of prompt engineering. And whenever anyone I'm overseeing, whether it's my kids or my wife or friends, when they're putting something in ChatGPT or Bard or one of the other ones, I'm always educating them how you ask. What you get back is only going to, your output's only going to be as good as how you ask it. And you have to speak in the LLM's language, i.e. prompt engineering. To me, that's one of the easiest things for all of us to master, where you don't have to understand the X's, O's, and in order to really take charge of that. So it just fascinates me.
Yeah, I totally agree. And it's for all, but it's for technical teams also, because right now you can use prompt engineering to enhance the development process, software development process, for example, and you can use prompt engineering to enhance and to improve absolutely the results that you can achieve with
And
large language
smart,
models.
smart software engineers are not intimidated by the advancements in generative AI. The smart ones learn how to use it to make them more productive. I would bet in my lifetime, Antonio, I'm a little older than you, but AI is not going to replace software engineers in my lifetime. Maybe yours, but probably not mine.
Okay, no problem. But that's a good point. That's a good point. But I think maybe for the future, maybe we will talk about later on in this presentation. But for the future, I think we will need technical engineers for different software development processes. But obviously, we will use artificial intelligence to enhance the process, right? So
No doubt.
that's good. So we should talk about the monitoring and filtering and reviews as another approach to mitigate the limitations of the large language models, when we are talking about a system based on large language models, we need to monitor, maintains, and maybe sometimes, depending on the answers that we are getting, we need to filter and we need to review the answers. So we can automate part of this process or maybe the whole process, but this is an important part in the to mitigate the limitations of the large language models. Later on, I will talk about the memory because this is part of the large language model operations that we use with the framework that we will talk about. And another important part to mitigate the limitations of large language models is fine-tuning, the fine-tuning process. So we have two options or three options. We can train our own large language model from scratch. I mentioned that, the limitations to that. But we can use prompt engineering or we can use the fine-tuning approach. With the fine-tuning approach, we can train our own large language models, taking advantage of all the knowledge that we have, for example, from GPT, Llama, or whatever you want, for a specific task, presenting a very huge amount of examples that we have, our own data set, and we can adapt the large language model to do some specific task. So that's another type of approach that we can use to mitigate the limitations. So when we're talking about the limitations of large language models, we will have challenges. For example, compositional reasoning or the breakdown problem, training enhancement, for example. But using the large language model operations, we can tackle all of them. And we should talk about the integration process, for example, the context and the interface, ethical, for example, safeguards, external data, and all of them lead us to the large language model operations paradigm, right? Because it will provide a structure and oversight for responsible LLM use. So go to the next one, please. So to tackle those limitations, we need to think in the approach and the data quality. So I would like to say that the approach is to develop a comprehensive approach or system combining data preparation, vigilance, and ethical designs, and all of the things that I'm mentioning here. Because we can use RAG, for example, retrieval augmentation generation, all of the features that we can use right now to achieve better results and to design very powerful architecture. So the approach is the first thing that we need to keep in mind, and the data quality is the other side. Data quality is very important because if we are trying to use not only for fine tuning, because sometimes we can think that I need data quality, I need a good data set because I'm planning to retrain or fine tune a large language model. Not only for that, because remember that we can use prompt engineering with examples. We have very different approaches in prompt engineering, and data quality is very important. Right?
Garbage in, garbage out, right?
Yeah, that's good. And to leverage the large language model with large language model operations, we will talk about the integration process. When I talk about integration process, I mean we can use different sources, data sources, and resources at the same time, in combining the powerful of the large language model. So we can integrate all of them. Uh, we should talk about solving operational challenges, for example. That's a very key point when we are talking about large language models operations, because this paradigm addresses common challenges associated with using LLMs alone, such as lack of external knowledge, for example. We can customize our system. This is very, very important because here an LLM is just a part of our system, right? We can develop a web application to call an LLM to get a response. That's very simple. But here, when we are talking about LLM ops, where we can see that the LLM is just a part of the whole architecture that we have. So that's the customization part. And obviously, when we're talking about processes in industry, we have a very dynamic day by day process, right? So that's very important. We can deal with that when we use large language model operations. Let me go to the next one, Steve. So here in this pair of graphs, we're saying that we have a very general machine learning solutions architecture when we have a business understanding, the identification and verification of the machine learning techniques, the machine learning platform that we are planning to use, automation, security, right? But in the center, we can see that we have the system architecture of the machine learning technology platform. Take a look that I'm talking about machine learning. Remember that deep learning is part of of machine learning, and generative AI is part of deep learning, right? So in this case, when we are talking about large language models, we are yeah, and large language model operations, we are talking about the diagram that we have here in the bottom, right? So if we take a look at this diagram, we can develop a very good solution, a very powerful solution for a specific problem in our business using this strategy. Um, Suppose that you have a web or a mobile application. When you get a question, for example, from a client using a front end, and behind the scenes, you can deal with that questions using prompt engineering, for example, not only the zero shot approach, but also the others approaches that we have. And look at this part of the diagram when we are talking about a loop. We are talking about a loop inside a large language model because here we can use different resources. Yeah, we're not depending just on the response that we can get from a large language model. You can use another resources here. And finally, we can use an output parsing, and with the knowledge that we have in external resources, we can get a very accurate response for our specific task in our application. That's a general diagram to show how we can use large language models. Go to the next one. So here it's very important to consider that we have three main aspects to keep in mind. The first one is LLM Ops pipeline, when we will have the model training, data processing, testing and debugging, and visualization. This left part of this chart is related with the training process, right? But that's not all. We need to consider that we will have a model operation hub. So we need model management, serving resource management, and optimization. And finally, we need a continuous improvement and monitoring, right? We need to monitor feature engineering, performance monitoring, and automation. We need all of these aspects in order to build a very powerful architecture based on large language models operations, right? Go to the next one. And we may wonder how can we do that? How can we achieve that? Because that's very impressive. So I would like to say that we have several frameworks to do that, but maybe LangChain is one of the best. Right? It's the best, and that's a very good option to do that. Why? Because LangChain is an open source Python framework uh, for building large language model powered applications. And with LangChain, you can simplify the development of sophisticated architectures and systems based on large language models beyond a basic call, uh, because remember that I mentioned that you can build web applications to call a large language model to retrieve something, right? But we're talking about a more complex environment here. So beyond a basic LLM API usage with LangChain, we can orchestrate a very powerful system. So that's very, very interesting. For example, we can develop a very powerful chatbot, such as ChatGPT or wherever you want using line chain. And how does it work behind the scene? That's a very important aspect. LangChain allows to work with chains, agents, memory, and tools. What are chains? Chains, you can think in a chain as a sequence of call of components. So maybe you can have different components based on different responses from large language models. So you can split complex tasks in subtasks, and you can think in each subtask is a component of your system. So with change, we can deal with that just with a couple of lines of code, for example. That's very impressive. And then we have agents. With agents, we can orchestrate all the system because we can say what chain I want to run before others and what response I can combine. I can combine with others in order to achieve most accurate response. And memory, for example, prevents chains from running in isolation, right? Because that's a very important aspect when we are using large language model. We need memory in order to achieve better results. And finally, the final component is tools. And this is a very important part because when we are talking about this type of architectures, we maybe sometimes we need to call all their resources, all their applications to do something. And we want to combine all the results in order to achieve the goals that we have for a specific task. So I would like to say that maybe when you use large language models for maths, you can achieve a good result, but sometimes not, right? So maybe you have a very powerful tool for your company to do some a very specific task, and you can call that using line chain, and you can combine all the results and retrieve a very accurate response for your clients. That's good. Go to the next one. And finally, this is a summarization of the process that we have behind the scenes in large language model operations. You can think that we have an application when we receive a user query, and using LangChain, we can orchestrate all of these components. So we can use the agents to deal with the query that we are receiving, and we can call different large language models for different tasks. We can save the responses, and then we can decide automatically if we need different tools to do different subtasks. And we can call all of them, and then we can orchestrate all the responses to achieve the goal that we are looking for. So that's a summarization of large language model operations.
Thank you, Antonio. Hey, so we got a great question. I'm going to flash up here on the screen. Oop, maybe if it works. All right. So from Nazar, we have a good question here around identity and access management in Gen AI models. Antonio, what's your take on this? This is a good one. Nazar, thank you for the question.
Let me think and make an accurate response. Okay. I think that this is a very, very specific question. That's very, very interesting. Maybe with LangChain, we can tackle this type of use case, but I think that's a very specific question. We need to review where the goals and restrictions that we have, but maybe using generative AI, we can tackle that. But I can see that that's a very, very specific question. Maybe I think for an accurate response.
Yeah, I mean, and if you think about it, you have the IAM, what's controlling what resources to get to what, and then you have the processing engine. And so depending on the rules for different roles, that can definitely be a tricky one, which I'm glad you asked, Nazar. Thank you.
Yeah, I would like to say that maybe we can think and those different tools as the tools that we have in this diagram, and we can orchestrate all of that. That's a very good question.
Uh,
And
to
I think
me, that question is a whiteboard exercise to understand the access level, the data resides. But
Mhm,
great question, and we appreciate that.
mhm.
Another question that we've gotten from previous workshops that we wanted to address that are common questions we hear. The question is, since LLMs are constantly evolving and changing, and you build an agent, say using Llama, how easy is it to, whether you're changing or updating or switching LLMs for your model? Antonio?
Yeah, there is a common use case, as I mentioned in this answer. And obviously, with the methodology and the paradigm that I showed in this AI workshop, we can tackle this, right? Because, large language models are constantly evolving and changing. And using, for example, LangChain, you can monitor the responses, and you can monitor all the process that you have in your architecture, in your solution, and you can decide when to change the large language model on when to update a large language model. So it is completely possible using LLM ops, as I showed.
Excellent. Next common question we get is always around, and everybody's concern with AI is how you measure and ensure the data quality.
Yeah, that's a very interesting question. And maybe we need to say that we have two options. The first one is a manual validation to performed by experts, for example, in the clinical data. That's a very common process because we need a very high accuracy in the system that we are trying to deploy in healthcare. So the manual validation is used to do that. But talking about LLM ops, we can use an automatic validation, for example. And the validation process might include some of the following steps, as you are seeing in this slide. So it is completely possible, and it is a very important part of the maintenance and the monitoring of this type of systems. So we can do that using LangChain also, because we can orchestrate not only the training, the deployment, but also the maintenance and the validation of the answers that we're getting.
Excellent. Thanks, Antonio. I know that's a big question. We had a question come in from Matt that if you use a company like Kindo, you can control the data that is reacted in the company behind them. And any comments on this, Antonio?
Maybe can you give me more details about Canada?
And yeah, I don't think we've dealt with Kindo in our current. So I guess Matt's giving a suggestion here that Kindo is a AI management tool that could be helpful. We appreciate that suggestion, Matt. That is, there are so many tools out there, and anyone who says they know all of them, they're lying. But thank you for that, Matt. Appreciate it. All right. So some other commonly asked questions we get, and we appreciate as we're wrapping up here, everybody taking the time to hear the workshop. Appreciate the comments and contributions. With Sononify technology, we do offer after doing a one-on-one workshop, we will create a custom model demo specific with your data, specific to a problem you're trying to solve. We don't charge for this. We have clients in healthcare and life sciences, fintech, as well as other industries. We're typically building private environments for companies that have a lot of data, that are looking on how they make the best use of that data. We often build these demos either on AWS, on one of our instances, or we also use client environments as well for that. Typically takes us 2 to 3 weeks to get a working demo up and running. And we often do these that tech leaders can use these as proof of concepts with their external team to get buy-in throughout the organization. And we've seen people have very good luck with that. With that, really want to thank everybody for taking the time to attend our workshop. Feel free to reach out to us anytime. And we offer free AI analysis roadmaps, the free customized demos we talk about. All you have to do is email us, reach out to us, and we'll also give you an ebook on LLM Ops with the information that we have covered here. And so once again, really want to appreciate everyone's time. Antonio, as always, great job. You have a rare ability to talk very technical and teach people at all different levels. And so appreciate it. I know our clients love it, and want to once again thank everybody.
Thank you. I appreciate it.
We're going to close this out. Everybody have a great rest of your day. Thank you.